Hi and welcome to today's class. We want to look at another aspect under differentiation application, and we are looking at curve sketching and particularly minimum and maximum point. When I say curve sketching, it's no big deal actually because you've plotted graph before, quadratic graph, and so on. It's also related to this. Although in this case we don't have to use measurements of measurements using rulers and the rest of that. All we're just looking for is an estimate sketch of the function, and two particular tools are needed if you want to sketch your curve correctly. They are the minimum and the maximum point. The minimum and the maximum point gives you a range of the change of y with respect to x, and that is why differentiation is very much important in curve sketching. Now, to begin with, for a quadratic function, you can only have either a maximum or a minimum point. You can't have the both at once. Your questions have come across, they will ask students to find the minimum point, find the maximum point of a graph that was plotted, maybe quadratic graph, and that one is easy to find, but when we are now looking at um, cubic functions, quartic functions, and so on, this kind of function, the curve behave differently. They may have two or more, a maximum, minimum points, and also they have point of inflection. In particular, starting with cubic functions, we have three things. We have the minimum, the maximum, and the inflection point. Look at this. These are examples of quadratic curves. Here you are going to have the minimum point. The minimum point is the lowest point the curve can achieve, and it corresponds to a y and x value, although the y value is the major determinant of that point. All right, and then we also have this. When you have a graph like this and it's going the other way around, you definitely know that you're going to have a maximum point. The maximum point is the highest point the graph can reach, the highest point the curve can get to before descending. That is what the maximum point is all about, and it corresponds to a y value and an x value. So the y value will be along this place, while the x value will be somewhere here. We can call the y value y1 and the x value x1, as the case may be. So the combination of these points is what we call the maximum point, and the same thing for the minimum point. But like I said, when we come to cubic and quartic functions, it's more than that. All right, apart from the minimum and maximum point, we also have the inflection point. The question is, what is the inflection point? You'll know what minimum point is and what maximum point is. So what is an inflection point? Now, an inflection point, the point of inflection is the point where direction of the bending you see the curve is bending. Is bending inward or is bending outward? All right, now the point, a particular point where the direction of the bending changes, is what we call the point of inflection. That is what the point of inflection is over. So here you can tell this is the maximum point, you can tell this is the minimum point. Somewhere around here is an estimate point, a value. Somewhere around here is that interface whereby one side of the curve was closing, while the other side, the concave, was opening. So that point is called the what? The inflection point. So we can say this is the inflection point. That's the point whereby the the bending is going to change direction. Now, all of these are known as the word stationary point. We say they are stationary point. Now, let us describe further what that means. All right. That means at stationary points, our dy over dx will be equal to 0. So that is the first thing you have to look for, where the change in the function, that is the y over dx, and then you equate it to 0. Thereafter, you will go further by determining, that's the number one, you determine the second, you take the second derivative. You take the second derivative over the x squared. When you take the second derivative of the function, the last thing is that you want to test if this over this is greater than 0, comma, we have the minimum point. Okay? Now, if second derivative is less than 0, we have the maximum point. And then if you can get this to be equal to 0, we have the inflection point. So that is how to determine the what? How to determine the minimum and maximum points. Okay? So in the next video, I will be taking a question whereby we find all the stationary points of that given function, and then we discriminate, we distinguish them between the minimum and the maximum points. Thank you.